Good afternoon, everyone. Today we are discussing concepts on series. There are a lot of competitive exams which have a lot of questions on series types. So there might be basic AP, GP series. There might be mixture of these. There might be sum of series. There are a lot of various types that we are going to cover today. So we'll start with the very basics, and as we move forward, we'll try to understand shorter methods of handling any type of series problem. So that would be the main objective. But keep one thing in mind. I always do this, and I always recommend every student of mine to do the same thing. After knowing these concepts and practicing this for a while, it's very important that you understand that if a series is if you have a series question in front of you and it is not clicking to your mind, what would be the best solution, or what would be rather the solution to get to the answer, it's better to skip that and move to the next question. If it is in a paper, if you're preparing, yes, you can give it a shot, try it again and again. So as you prepare more, you'll get more more exposure towards different types of series, and then you can carry forward from that. But when it comes to the actual test, it is very important that you do not spend too much time. Don't get stuck to a series question. Okay, so I can ensure you, if you keep these quite basic things in mind, the ones which we are going to discuss today, you'll always be able to attempt at least 80% to 90% of the series questions. Sometimes there are a little off the chart type of series which are too much observation based, which can be infinitely many types. So we cannot cover all of those types. So we are going to find a structured way of generalizing different types of series. That's the objective for tonight. So without further ado, let's begin with the very basic. So by the very basic, I mean the AP series. I hope everybody is aware of AP series. So let's start by taking an AP series here. So let's take this AP series simple example. I hope most of you might be aware about it. If you check, there's an increment of 3 on each term to give us the next term. Now, there are a lot of formulas of AP series. I'll discuss only one, and that is the faster way of calculating the nth term, and a very efficient nth term formula, which will be helpful in a lot of different types of questions. So the process that I apply is I observe the common difference here. So what is the common difference? That is 3. So first of all, without even thinking anything about it, I'll just write 3n. Now, using this 3n, let us assume that we have n equal to 1. So if I have n equal to 1, then 3 into 1, this part can be done mentally. So 3 into 1 will give us 3. And now my question is, if n is 1, my first term is actually 4. It's not 3, right? So 3 plus minus, how much should I add or how much should I subtract to actually get the first term? So first term is 4, so I should add a 1 to this. So same, you add the 1 here also. So now this is the nth term basically. So 3n plus 1, you substitute n equal to 1, you check, you get the first term. You substitute n equal to 2, you get the second term, 3, third term, and so on, right? Now you can take another example here. So let's say we have something like 7, 5.5, 4, sorry, 2.5, 1, minus 0.5, and so on. Now if you check here, the common difference is negative, right? Every term is reducing by 1.5 from the previous term. So again the same thing, I'll just write minus 1.5 n. Now this is important, you have to take the sign into consideration. The common difference is minus 1.5, so we are writing minus 1.5 n. So what you have is minus 1.5 n. Now obviously if I substitute n equal to 1, that gets a negative value, right? So plus how much would give us 7. So minus 1.5 into 1 is minus 1.5, plus how much will give us 7? 8.5, right? Now I'm just using the first term again. So instead of n, I'm just assuming n equal to 1, and then I get this part as minus 1.5 plus 8.5 will actually give us 7. So basically this is the nth term. So the nth term, I can even modify this 8.5 minus 1.5 n or something. So if you substitute, let's say n equal to 3, so n equal to 3, this would be what? 4.5. 8.5 minus 4.5 is 4. You can check the third term is actually 4. So this is a faster way of calculating the nth term of an AP series. So I'll just denote that by Tn. Tn is the general representation of the nth term. T for term, n for n is a suffix here. So nth term of an AP series you can figure out in this way. And please try to apply this process. It's a very easy process. If you practice it on 2-3 series of yourself, you make it yourself. Just apply it 2-3 times, and you'll have a habit of doing this in a jiffy. So let's move to something else. Now let us take some different types of series. Okay. First of all, let's take something like this. So 3x minus 1. What I've done is instead of n, I've just written it as x. So don't get confused with the x here. So we'll simply substitute x equal to 1, 2, 3, 4, and so on. The reason for taking s you'll get in some time here. Now if I take 3x minus 1, see the first term would be what? 3 into 1 minus 1, that is 2. Second term, you can calculate it yourself. It would be 5. Then you have 8, 11, 14, and so on, right? Keep on substituting n equal to 1, 2, 3, 4, and so on. X equal to 1, 2, 3, 4, and so on. Now, if you observe, the differences are constant, right? The first level difference, that is what I call them. The first level difference itself is constant. So you take the differences of the terms, and that is constant itself. Now let us take another series. So as simple as this, x is square. Let's take a square series or a quadratic series. So what you have is 1, 4, 9, 16, 25, 36, and so on, right? Now if you check the differences here, you have 3, 5, 7, 9, 11, and so on. Now these are not constant, but if you take the difference again, what do you get? 2, 2, 2, 2. That is constant, isn't it? So in this case, the second level difference, right? This is the first level and this is the second level. So let me write this as L1 and L2. So the second level difference becomes constant here, right? Now if we take something like x cube, even we can take something like x cube plus 1. It doesn't matter. Here also we could have taken something. The second level difference would have been constant. So if I take something like x cube plus 1, so 1 cube plus 1 is 2, 2 cube plus 1 is 9, 3 cube plus 1 is 28. So I'm just taking every term, one after the other. So x equal to 1, 2, 3, 4, and so on, as in the previous cases. So you can observe these are the values and so on. Now if you check the differences here, you have 7, 19, 37, 61, 91. Check the differences again. You get 12, 18, 24, 30. Check the differences again. You get 6, 6, 6. So the third level difference is constant, right? So this is L1, this is L2, this is L3. The difference is level 1, 2, 3. So the third level difference becomes constant. Now, many places you would have this concept given to you, but they'll stop here. Now, I'll go one extra level and I'll try to explain on why this happens. I'm not sure how many of you are aware of this. Let me move to the next page. I'll come back to here in a while. Now, I hope many of you, I hope most of you or almost all of you must be aware of the differentiation of x to the power n, right? I don't expect you to remember differentiation of anything else, just x to the power n. So x to the power n का differentiation क्या होता है? That is n into x to the power n minus 1, right? So the differentiation of x to the power n is n into x to the power n minus 1. Just by this knowledge, let us check this series here. You'll find something interesting. Now, the first series that we took was 3x minus 1, right? Oh, by the way, sorry for that. The differentiation of a constant term is 0. if you have a constant value, the differentiation of that is 0. So using these two ideas, if I check this, differentiation of 3x minus 1. So differentiation of 3x minus 1 will be 3 into differentiation of x and minus the differentiation of 1. Differentiation of 1, that is a constant value, that is 0. So 3 into differentiation of x. X ka differentiation, what would that be? 1. So simply this is giving us a differentiation of 3, right? So differentiation of 3x minus 1 will be essentially 3. And check the first level difference, that is how much? That is 3. Let us do the same thing here. The differentiation of x square is what? 2x. Apply the same logic. And what is the differentiation of 2x? 2. So if I differentiate this twice, I get a constant difference of 2. And that is what we get here, right? The second level difference. So differentiating twice, I get a constant value of how much? 2. Apply it here. X cube plus 1. So differentiating this, I get 3x square. The constant term is 0. So differentiating x cube, you get 3x square. Differentiating 3x square, you should get 6x. And then finally differentiating 6x, you should get 6. And that's what you get here, right? Now keep this idea in mind. So it's not just that the third level difference is constant. You can actually, understand by looking at the series what should be the third level difference, or vice versa. Vice versa as in, let me take an example here. Now, if you check this, check the differences here. You have the series given to you. You don't know anything about the series and what is happening here. So first thing what you do is you check the differences here. You have 14, 15 and 53 as a difference of 38. 53, 127, that's a difference of 72. 74. 127 and 249, that is a difference of 122. So these are the differences, right? Let me take the difference again. So 14 and 38, that's a difference of 24. 38 and 74 is a difference of 36. And then you have a difference of 48. Now, hopefully you can understand straight away that the next level difference is becoming constant. So first thing, here most of the books, solutions, and many institutes would actually tell you that this is a cubic series and start, and they'll start taking series like this and then start solving. I mean, put x equal to 1, equate it to 1, put x equal to 2, equate it to 15. So that's a very lengthy process, isn't it? So now, if you check here, the second level difference is constant and it is how much? 12. Third level difference is constant and that is equal to 12. Now we already know that if the third level difference is constant, it must be a cubic series, right? So suppose it has a leading part of ax cube, right? So let us assume it is ax cube. So if I differentiate it 3 times, you will find, you can do it yourself, you will get it 6a. If you differentiate it 3 times, you should get something like 6a. So our 6a must be equal to 12. 6a being equal to 12, what is the value of a? That is 2. Just by a little bit of practice, you can remember this. Third level difference being 6. If third level difference is 6, you started off with x cube. And here the third level difference is 12. So it should be double of x cube, right? So you should have 2x cube. So you now know the leading part. You know the leading part is 2x cube. Now all you do is put the values of x equal to 1, 2, 3, 4, few of them, and just try to compare the series with whatever you're getting here. So if you put x equal to 1, you get 2 into 1, that is 2. This is a series actually, this is a 2x cube part. If you put 2, you get 16. If you put 3, you get 54. If you get 4, put 4, you get 128. And I hope you can observe straight away that there's a difference of 1 of each term from the actual series. Is 1. How would you get the 1? You'll get the 1 by subtracting a 1 from this. From 16, how do you get 15? By subtracting a 1 again, subtracting a 1 again, subtracting a 1 again. So what should be the series? It should be 2x cube minus 1. So it's much faster way. I mean, it's not always that you should have a constant value here. You can even have something like an AP series. So you, instead of having 1, 15, 53, 127 and so on, you could as well add 2 minus 1 and 16 minus 2, 54 minus 3, 128 minus 4. You can test it out yourself. And I'll just give you the terms here. So 2 minus 1 is 1, 16 minus 2 is 14, 54 minus 3 is 51, 128 minus 4 is 124, and then the next term would be, this is, yeah, so that would be 244. If you just test this out, if you test this series out, you will again have the third level difference of 12. If you test the differences, you can test it out yourself. You will again have the third level difference of 12. You should have the third level difference of 12. Now, if you get the third level difference of 12, again you know that it is 2x cube. Now, all you need to do is test this term out. So 2x cube is the leading part. You already know that. Now, if you check at the series, the modified series here. So the first term is 2 minus 1. The second term is 16 minus 2. The third term is 54 minus 3. Now the subtracted part is not constant, right? But I hope it is very visible, right? I mean, the first subtracted part is what? Simply x. For the first term you get 1, for the second term you get 2, for the third term you get 3. Or what I'm trying to say, it's an AP series. And even if you don't have as simple as something like x, even for an AP series, we started our discussion by that. How to, find the general term of the AP series quickly. So that is where this part comes in. So instead of having a simple AP series, you can have a complicated AP series. So no problem there. I mean, you can just simply use that idea and you can find the general term quickly. So in this case, that is 2x cube minus. So this series is basically 2x cube minus x. But I mean, that's just an example. So hopefully you can make some series. What you can do is you can form some complicated cubic series and quadratic series of your own. Just write the series first. So just write out of your mind, 2x squared plus 3x plus 2 or something like that. Just write a series roughly. Do a bit of rough work. I mean, just calculate calculate each and every term by putting x equal to 1, 2, 3, 4, and hopefully don't make a mistake there. And after that, apply the same process. So if you take 2x squared plus 3x plus 2, your second level difference must be constant, and more importantly, the second level difference must come out to be 4. You can verify that. So you can just form series of yourself and try to find this general term of this series. So we'll stop this video here. We'll follow it up with other videos. In the other videos, the plan is we'll go one after the other. So these are the generic type of series. So generic series are more important. So once we discuss the generic series, then what we'll do is we'll move to summations of the series, and then we'll try to implement merged series, the series in which there are a little bit of observations and all. So we'll discuss these kind of series one after the other. So this is the first part of the video. Hopefully you